In section 3.5, we are going to look at how lines can relate to each other and how those angles that are created relate to each other. In the diagram, we have a line that intersects two other lines. When a line intersects two other lines, it's known as a transversal. I'm going to label this transversal T. Notice I'm using a lowercase letter to label a line. The two lines that are intersected by the transversal, I'm going to label R and S. When a transversal intersects two other lines, 8 angles are created. I'm going to label those 8 angles. Now the angles that are created have relationships to each other. If I look at angles 1 and 4, 1 and 4 are right next to each other, so they're adjacent. Their non-common side forms a opposite ray, which means that they form a linear pair. And since they form a linear pair by the linear pair postulate, those two angles have to be supplementary. 1 and 4 aren't the only angles that are adjacent, form a linear pair, and are supplementary. They're just an example. All of these will just be examples of the different kinds of angles. 1 and 3 are across from each other, which means that they are vertical. And by the vertical angles theorem, if two angles are vertical, then they are congruent. If I look at 1 and 5, if I draw a box around these 8 angles, angle 1 is in the upper left corner, and angle 5 is in the upper left corner. 1 and 5 are in the relative same position, which means that they are corresponding. 1 and 5 aren't the only corresponding angles, they're just an example. 1 and 7. 1 is in the upper left corner, 7 is in the lower right corner. If I look at 1, it's above my transversal, and 7 is below. Above, below, above, below. Those two angles are alternating, so they're alternate. And if I look at how they relate to my two lines that are being cut by the transversal, they are outside of those two lines, so they are exterior angles. 1 and 7 are alternate exterior angles. If I look at 4 and 6, 4 is above the transversal and 6 is below. Above, below, above, below. They are alternating, and this time 4 and 6 are both between R and S, so they are interior. Angles 4 and 5. 4 and 5 are both between R and S, so they're going to be interior angles, but they're on the same side of the transversal. When two angles are on the same side of the transversal and they're between the two lines being cut by the transversal, they are called consecutive. Consecutive means one right after the other, so 4 and 5 are consecutive interior angles. Angles 1 and 8. 1 and 8 are both on the same side of the transversal, but this time they're exterior. So 1 and 8 are consecutive exterior angles. These are examples of how angles can relate to each other. If I look at the postulates and the theorems that deal with the different kinds of angles that are created with a transversal, all of the postulates and theorems start with lines being parallel. The lines that need to be parallel are the lines that are cut by the transversal. If I take the exact same picture that I had and I make R and S parallel to each other, then I can use all of these theorems and postulates. These are the different kinds of angles. If my lines are parallel, then I can use these theorems and postulates. These all start with two parallel lines, so I'm going to mark R and S parallel to each other. The symbol to mark lines parallel is to draw little arrows on those lines. So if I have two parallel lines, which I do, then my corresponding angles are congruent. If I look at 2 and 6, 2 is in the lower left corner, and 6 is in the lower left corner. So 2 and 6 are corresponding, and I have parallel lines, so by the corresponding angles postulate, those angles are congruent. Be careful, not all corresponding angles are congruent. If I look at 1 and 5, 1 and 5 are definitely not congruent. 1 is obtuse and 5 is acute. So they're not congruent, they're just corresponding. What makes these angles congruent is my lines are parallel. If I shifted these four angles on my transversal, 1 and 5 would be right on top of each other, and they would take up the same amount of space. They would be congruent to each other. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If I look at 3 and 5, below and above, interior, they're between my two lines, then they need to be congruent. If I take these four angles and I slide these four angles on top of these angles, 5 is going to take the place of 1, which means that 5 and 3 would be vertical. And if they're vertical, that means that they have to be congruent. So 3 and 5 are actually congruent. My consecutive interior angles. If I look at 3 and 6, they're both below the transversal and they're between my two lines, so they're interior. If I slide these four angles on top of these four angles, 6 would take the place of 2. 6 and 3 would then form a linear pair, which means that they would be supplementary. So if I have two parallel lines, my consecutive interior angles are going to be supplementary. The measure of angle 3 plus the measure of angle 6 is going to equal 180 degrees. And my last theorem, the alternate exterior angles. If I look at angles 2 and 8, if I slide these four angles on my transversal to be on top of these four angles, 4 and 8 would be in the same spot, which means that 2 and 8 would be vertical, which means that they would be congruent. So 2 and 8, because my lines are parallel, are going to be congruent. Now be careful with these postulates and theorems. These are only true if my lines are parallel. If my lines are not parallel, I can still name those types of angles. I just can't conclude that they are going to be congruent or supplementary. The last theorem that we're going to go over is the perpendicular transversal theorem. The perpendicular transversal theorem has one big long if statement. If a transversal is perpendicular to one of two parallel lines, well, this is where I need to start. Two parallel lines is part of my if statement. These two lines have to be parallel in order to use the perpendicular transversal theorem. and I have to have a transversal that is perpendicular to one of those lines. So I'm going to draw in a transversal and make it perpendicular to one of those lines. My if statement actually has two parts. If my lines are parallel and my transversal is perpendicular to one of those parallel lines, then I can conclude that the transversal is perpendicular to the second line. And that makes sense. If this is a right angle and I have parallel lines, this has to be a right angle because they correspond. If this is a right angle, then this transversal is perpendicular to my second parallel line.